Interpolation is another important feature of Monospost Developer. Rotary axis interpolation is almost needed in every post processor, when performing simultaneous 5-axis operations. Without interpolation, there is always a risk of sudden change in rotary axis. This is true, both for CNCs with TCPC function, and those without TCPC. TCPC is a general term for NC controllers. This special code allows simultaneous operations to be performed smoothly and precisely. TCPC code for FANUC controller is G43.4. Other controllers have their own codes. Rotary axis interpolation is a must for CNC machines without TCPC functionality. On such kind of CNC machines, you can still perform smooth and precise simultaneous 5-axis cuttings with rotary axis interpolation feature of Monospost Developer. Although activating rotary axis interpolation is not a must for CNCs with TCPC function, rotary interpolation enhances the quality of the cut, and therefore should also be activated for such kind of machines. Linear interpolation is required when mill-turn CNC machines do not have special NC codes for polar milling. Polar milling code is G12.1 in FANUC, other controllers have their own codes. When your machine doesn't have polar code, you can still perform polar milling operations by activating linear interpolation in Monospost Developer. Let's see how interpolation parameters are used. To activate interpolation, just select True for use interpolation. You can define different step sizes for X, Y and Z linear axis. Rotary axis interpolation step sizes are determined by 3 independent parameters. These are vectoral, rotary axis 1, and rotary axis 2 angular step sizes. Monospost Developer uses all these 3 parameters to define the interpolation steps for rotary axis movements. You can enable linear or rotary axis interpolations, or both, by increasing or decreasing these step sizes. For instance, if you define bigger values for X, Y and Z, this will deactivate linear interpolation. Similarly, if you define bigger values for rotary step sizes, this will deactivate rotary interpolation. Entering lower values for both, activate linear and rotary interpolations at the same time. Let's now look at some examples. I will first generate an NC code without activating interpolation. Then I am generating a new NC program after I've activated interpolation. Since both linear and rotary step sizes are low, both interpolation is active. Let's compare the results. This is a 3+2 axis operation, there is no rotary axis change, and therefore only linear axes are interpolated. As you can see, second NC program contains much more NC lines, due to linear interpolation. Longer movements are divided into smaller steps on the right. There is something interesting here. Although we enter smaller values for rotary step sizes, simultaneous operations aren't affected from interpolation. How did that happen? This can only happen if there is another linear motion event activated in simultaneous operation. Let's check that. I click the blue button on the right. Then I select the linear motion event. The bold fonts show the operations on operation tree that have the same event defined. And as I've expected, simultaneous and angular operations have their own linear motion events. Therefore, the adjustments we have made didn't affect simultaneous operation. Let's check the action linear motion in simultaneous operation. Interpolation is already activated. I will cancel the interpolation now, and generate a new NC program to see the difference. Let's look at the differences. C-axis movements are lower than 1 degree on the left side, where interpolation is active. On the contrary, second NC program has C-axis movements, approximately 4-5 degrees. You can also see that second NC program has less NC program lines due to cancellation of interpolation.